You are welcome to Chapter 2, Indices and Logarithm.
Content. In this topic, we will understand the laws of indices, simple exponential equations, logarithms, anti-logarithms, calculations using logarithms, and the theory of logarithms. To effectively understand this topic, you need writing materials, logarithm and anti-logarithm tables, and a scientific calculator. Introduction. 2 raised to the power of 3 means, so a raised to the power of 3 equals a times a times a. 3 is the index or power or exponent, and a is the base. Law 1. The law of addition. For example, 5 raised to the power of 2 times 5 raised to the power of 3 equals, and it gives 5 raised to the power of 5. To check, 5 raised to the power of 2 times 5 raised to the power of 3 equals, that's 5 multiplying itself 5 times, and that gives 5 raised to the power of 5. Law 2. The law of subtraction. For example, n raised to the power of 5 divided by n raised to the power of 2 would give n raised to the power of 3. To check, n raised to the power of 5 divided by n raised to the power of 2, n multiplying itself 5 times, all divided by n multiplying itself 2 times. And when you cross them out, it gives you n raised to the power of 3. Law 3. The law of products of indices. For example, 4 raised to the power of 3 all raised to the power of 2 equals, and it gives 4 raised to the power of 6. To check, 4 raised to the power of 3 all raised to the power of 2 equals, and this gives 4 raised to the power of 6. Law 4. Law of negative index. For example, 5 raised to the power of minus 2 equals, and this gives 1 over 25. To check, 5 raised to the power of 2 divided by 5 raised to the power of 4. From the law of subtraction, this gives 5 raised to the power of minus 2. Also, 5 raised to the power of 2 divided by 5 raised to the power of 4 is 5 times 5, all divided by 5, multiplying itself 4 times. And when you cross it out, it gives 1 over 25. Then, 5 raised to the power of minus 2 equals 1 over 25. Law 5. Law of fractional index. A raised to the power of 1 all over n equals nth root of a. For example, and this gives 3. And this gives 2. Law 6. Law of fractional indices. A raised to the power of m over n equals n root of a all raised to the power of m, or n root of a raised to the power of n. For example, 16 raised to the power of 3/4 equals, and this gives 2 raised to the power of 3, which is equal to 8. Note, in most cases, it is better to take the nth root first and then find the power of the result. Alternative method. You find out that for larger numbers, it takes time. Law 7. The law of special indices, or law of singularity. For any number raised to the power of 0 is equal to 1. For example, 6 raised to the power of 0 equals 1. To check, 6 raised to the power of 3 divided by 6 raised to the power of 3 equals, from the law of subtraction, 6 raised to the power of 0. Also, 6 raised to the power of 3 divided by 6 raised to the power of 3 equals 1. Then, 6 raised to the power of 0 is equal to 1. Example 3. Looking through the solution, recall the different laws of indices that were used in solving the question. A summary on the laws of indices. The law of addition, a raised to the power of m times a raised to the power of n equals a all raised to the power of m plus n. The law of subtraction, a raised to the power of m divided by a raised to the power of n equals a raised to the power of m minus n. The law of product of indices, a raised to the power of m all raised to the power of n equals a raised to the power of mn. The law of negative index, a raised to the power of minus n equals 1 all over a raised to the power of n. The law of fractional index, a raised to the power of 1 all over n equals nth root of a. The law of fractional indices, a raised to the power of m all over n equals the nth root of a all raised to the power of m, or the alternative method, n roots of a raised to the power of n. The law of special indices, or the law of singularity. A raised to the power of 0 is equal to 1. Remember, in each case, A is not equal to 0. Simple exponential equations. Consider the equation 3 raised to the power of x equal 81. The unknown x is the power or index or exponent, and the base is 3. We can solve such equations by expressing both sides in terms of the same base. We know that 3 raised to the power of 4 is 81. We can now equate the powers. In general, if a raised to the power of m equals a raised to the power of n, then m is equal to n. This simply means if both sides have the same base, then the indices are equal. Similarly, if a raised to the power of x equals b raised to the power of x, then a equals b. This also means if the index is the same, then the bases are equal. Let's consider the following examples. To simplify this equation, we divide both sides by 2. To find the unknown, we express both sides to the same index. Since they have the same index, we now equate their bases. And this gives us r equals minus half. In this example, to find the unknown c, we express both sides of the equation to the same base. We can express the terms in base 2 or 4. Using these examples, solve the following equations.